This is a review of graphing inequalities. Inequalities. So they're not equations, they look like equations, but there's an arrow, a greater than or less than arrow. In this case, a greater than arrow and an equal sign. So we've got an x and a y. We know when we have an equation with an x and a y that it takes two numbers to make a solution, and that there are infinite pairs of x's and y's that will solve this. And so we can't list all of them. The best thing we can do is draw a picture on a graph. So let's do that. But this equation isn't in slope-intercept form, or y equals mx plus b form, and that makes it easier to graph. So let's get it into y equals mx plus b. We want the mx on this side, the 3x on this side, so I will subtract 3x. I have to do the same thing to the right side, and I'm left with 4y is greater than or equal to, and we're going to write negative 3x plus 8. We don't want to say 8 minus 3. We can't, because they're not like terms. This is an 8, this is a 3x. All right, now we have this 4 in front of the y. We want y alone so that it will look like y equals mx plus b. So I need to divide by 4 on both sides of the equation. The 4's turn into 1. 4 divided by 4 is 1. That leaves me with 1y. I'm happy now, that's what I wanted. And then we're going to leave this as negative 3/4 x plus, and 8 divided by 4 is 2. All right, so we have y is greater than or equal to negative 3/4 x plus 2. Okay, we're going to go and graph our solution now. So I'll draw my xy coordinate plane. There's the x-axis. There's the y-axis. Now, we know this is the y-intercept, which means the line crosses the y-axis at 2. So we know there's a point at 2. And the slope tells us the rise over the run. The rise are the y values, the run is the x value. So the rise, the y's, are going to go down 3. So 1, 2, 3, and it's going to run positive 4. Remember, don't put the negative on both numbers. So negative 3 is down 3, positive 4 is right 4. 1, 2, 3, 4. Here's another point. So if we connect these, we get this line, and every point on that line will make this equation true. But because there's this arrow, there's other points that will make the equation true. So remember, with inequalities, we have to shade one side of the line or the other. And do you remember how we decide to shade which side of the line? Remember, we like to put in a test value and see if it's true. And the test value we like to pick is 0, 0. So let me put 0, 0 into our inequality and see if it makes it true. So is 0 greater than or equal to negative 3/4 times 0 plus 2? Let me clean that up. Is 0 greater than or equal to, well, negative 3/4 times 0 is 0. Is 0 greater than or equal to 2? No. 0 is less than 2, so that's false. That means this test value is on the side of the line where all those points are not going to make this true. So we want to shade the other side of the line. This then is the solution to this inequality. Every point that falls on the line and every point that falls in the red shaded region. Let's do another example. 3x minus 4y is greater than 8. Let's see what's different here. Caught it. Instead of a plus, there's a minus, and instead of a greater than or equal to, it's just a greater than. All right, so let's go through the same steps. Let's get into y equals mx plus b. So we're going to subtract 3x. Now this one's a little trickier. When I subtract the 3x, I'm left with a negative 4y. You got to hang on to that minus sign. It becomes a negative sign. greater than negative 3x plus 8, just like we did before. Okay, this time we're going to divide by negative 4. Do you remember that special rule that when you multiply or divide both sides of an inequality by a negative, the arrow has to flip right, you remember that, the arrow has to flip the other way. So those cancel. I have y is less than, and I've got negative 3 over negative 4. A negative divided by a negative is a positive. And then 8 divided by negative 4, a positive divided by a negative is a negative. Okay, so we're going to go and graph this. Let me draw my coordinate plane. All right, this is x, this is y. The y-intercept this time is negative 2. So my line crosses the y-axis at negative 2. And then we're going to go up 3, right 4. They're both positive. Up 3, right 4. So 1, 2, 3, 1, 2, 3, 4. So there's a point there. Now let's say you looked up at this fraction. That would be okay too. But it's negative 3 over negative 4, so you would have to go down 3, left 4. And you can see that that does put it on the line. All right, what kind of line are we going to draw? Well, the line looks like that. But because it is just a less than sign and not an equal to sign, that means all the points that fall on the line won't make that true. But we need the line there for a boundary between the side we're going to shade and the side we're not going to shade. So remember what we do to leave the line, but let everyone know that, hey, this line's just a boundary. The points on the line actually don't make this true. Right, we make a dashed line. So I'm going to erase part of the line so it looks dashed. Now, which side do we shade? Let's put in our test value of 0, 0. Is 0 less than 3/4 times 0 minus 2? Is 0 less than 3/4 times 0 is 0 minus 2? Is 0 less than negative 2? Is 0 less than negative 2? Now, careful, in your mind you might think 0 is less than everything, but actually 0 is greater than negative numbers, because you'd rather have $0 than owe $2. So 0 is actually more than negative 2. So this is false. Therefore, this point is on the false side, so I want to shade that side. All right, so that should about cover all the examples that you might run into. So you've got to get it into y equals mx plus b, graph your line, decide which side to shade. Make sure you're asking, is it a dotted line or is it a solid line? And be careful for flipping arrows. When you divide by a negative, the arrow flips. A dead giveaway is when you've got a negative sign on the y. Somewhere in the problem you're going to divide by a negative to get rid of that negative, and that's what's going to flip the arrow. So if you get good at these, you can just tell before you even start if it's going to be one where you flip the arrow. All right, good luck with those exercises.